Okay, so we'll start now. So today, what we are going to discuss is the cooling system. So good morning to all of you. Today class, we will be discussing the purpose of the cooling system operation, the components of it, and what sort of problems usually comes with the cooling system and how to actually fix those sort of things, right? So those are the things we will be discussing today. So I know you have already learned about the cooling system, but I will start from the beginning. So cooling system at this stage, so in the beginning, we will be only discussing about the engine. So main engine structure, that is the engine block and the head cooling. And next we will be actually discussing a little bit about the rest of the components as well. So even though we only consider, when we talk about the cooling system, we only consider about cooling of the engine, that means cylinder block, only about the cylinder blocks, but other components such as the alternators, AC compressors, the turbochargers, so any other components, gearboxes, differentials, all of these components actually need cooling. In some cases, actually in most cases, the atmospheric air which is actually passing through the vehicle is enough to cool itself. But in special cases, if the component is working harder, then it actually needs some additional cooling. One good example is suspension, the coil suspension, the shock absorbers. Shock absorbers, also known as struts, actually we know that there are no cooling system available in a normal suspension, because that suspension, even though it's working hard, the cooling it's received from the passing air around it is actually enough. But in some cases means high performance applications and any like racing applications, such applications, the coil spring, hydraulic struts or shock absorber needs additional cooling. In such cases, they have additional cooling reservoirs to actually cool the hydraulic systems. Similarly, for other components as well, there are additional cooling systems are available in if it is necessary. That's one of the reasons. I think you might have heard this. What's this? Bugatti Veyron, the world's fastest car, some time ago, actually had 10 cooling radiators. The reason for that is since it's actually designed to develop more power, it may need additional cooling. For example, engine oil. We discussed about this one in the last class also. Engine oil needed cooling. If it is actually working hard, again, this part will come again later on. So yeah, so cooling system. The purpose of the cooling system is actually absorb the heat that actually generated inside the combustion chamber, right? The combustion chamber and any other components, and dissipate the heat outward. So they take the heat and remove it from the combustion chamber without affecting any of the components. That means since there's a combustion happening, because of the combustion, all of the components inside the combustion chamber, that means the piston, the cylinder walls, rings, and everything actually get hot. So that temperature, if it continue to work in this particular temperature, without adequate cooling, what actually going to happen is the expansion of the metal components, that means the cylinders and piston rings. So that expansion actually going to go exceed the limit that can actually withstand by the components, which result in actually stuck, or we call this as a ceased engine. Engine is going to cease because the engine coolant is not actually absorbing the cool temperature from the engine. So all the components expand. That means the piston, right? The piston, inside the piston rings expand, and it got stuck in the piston, in the cylinder itself. So the piston can't actually move. So that will result in catastrophic damage. So to avoid this, the cooling system has to actually take the heat away at all times. But there's a downside, right? Downside means, So when the engine is actually cooling, right, as you know, it's actually running using the using a pump. Water pump is actually taking the coolant out. So any sort of system can be used. Either it could be air cooled or water cooled or whatever it is. So whatever the system it use, it should actually maintain the operating temperature as well. So maintain the operating temperature means engines needs to have a engines supposed to have a particular operating condition, operating temperature. The reason for this is, so all the components are made in metal, right? So these metal components have to expand up to a certain extent and close if there's any gaps in between. One example is the piston rings. So you might have seen piston ring looks like this. So there's a gap, or it's called as a slit, right? So this gap, someone's mic is turned on. Can you guys? Mic is on. Ampat, your mic is on. Please turn off the mic. Okay. Right. So there's a gap here, right? The reason for having this gap is to actually expand and close this gap. So that means at 25 degrees Celsius, right? That means our normal rooming condition. This looks like this, right? 25 Celsius. So at 25 Celsius, this gap is like that, right? But once it goes up to around when the engine is started, once the engine started, it goes up to the operator. It's actually temperature increase. There's a particular temperature that engine needs to run properly. So at that particular temperature, this gap will be actually fully closed, right? Fully closed. So that gap is completely closed. So now there are no leak between, or there's no contact between the combustion chamber and the crankcase. So it's fully closed. So in this temperature has to be maintained. Until this temperature, engine actually have to increase the temperature. After it comes up to this temperature, it should not actually exceed that, because if it try to exceed this temperature, what happened is now expansion is outward, right? Expansion is now outward. There's no way to actually expand, which result in this uh, this compression or piston rings actually going to go and will be stuck in the piston wall, sorry, cylinder wall itself. So to avoid that, engine actually have to keep it at a constant temperature, also known as optimum working temperature, right? So this optimum operating temperature is around 80 degrees Celsius, right? 80, so it's actually varies between like 76 to 95 based on the engine and what sort of materials used in the component. But usually we say it's around 80 something degrees, right? So the engine actually have to maintain at around 80 degrees. So maintaining at around 80 degrees is the other function. So one is removing excess temperature, but the other thing is it should maintain at this operating temperature. So it should not actually allow the engine to go below this temperature, because if it goes below this temperature, there will be a gap here. So engine is not efficient as it can be. And if it goes over this temperature, then in that case, engine is actually, there's a possibility of engine may have higher wear, right? Higher wear could be actually occurred in this case. So to avoid this, engine should always maintain this temperature. So just having a coolant or air flow around the engine is not actually going to help this. Okay, so that's what actually mentioned here as well. So as much as adequate cooling is needed, it should actually maintain operating proper operating conditions. So that's one of the main reasons for having such a complicated cooling systems in the vehicles. In addition to that, if you are aware of the environmental conditions, if we consider environmental conditions few years or few decades back, like 30-40 years ago, the temperature of the environment is actually lower than what we have at the moment, right? What we have at the moment. At the moment, the temperature, environmental temperature has been increased by 1 or 2 degrees or something like that. That 1 or 2 degrees, even though it's not a very big amount, it's actually a huge difference for all the other things that could actually make a huge difference in the engines or any other. Even the environment is actually the environment. Even for example, nowadays most of the areas in Sri Lanka, it's actually rain, right? That's a very good example. That's rainy, but it should not actually rain in August. August is used known as a dry season, but it's summer. But in the middle of the summer now it's raining. So these sort of things actually happen because of these temperature differences, temperature increase in the environmental temperature increase because of the all the emissions and pollution going on in the world itself. But that again going to actually affect this engine and the designs and how the components works, coolants, everything has to be actually yeah, should be able to operate in these conditions. So that's one of the reasons we will be discussing this one again later with the cooling systems. So coolant system is actually utilized, right? It's actually utilizing the heat transfer phenomena, right? Heat transfer phenomena. Heat transfer phenomena means in heat always actually transfer from higher temperature body to a lower temperature body, right? Heat always transfer from a higher temperature body to a lower temperature body. It never travels the other way around, right? This heat transfer, or this traveling of heat, actually happens in 3 levels, right? Three methods. So these 3 methods are actually known as conduction, convection, and radiation. I'm not exactly sure whether you learn these things, but I'll just go ahead and explain these things very simply. So convection, right? We'll start with the convection. The movement caused within a fluid by tendency of hotter and therefore its less dense materials to rise and colder dense materials to sink under the influence of gravity, right? So very simple example is, so if we sorry about the noise. Yes, so very good example. You might have seen these air balloons, right? Air balloons that sort of looks no air balloon, I guess. Air balloon sort of like this basket is here, right? So here there's a air is actually filled in this, and there will be a fire, right? Fire that overheat, right? Heat the air inside. So when it actually heats, what actually happens is try to expand. By expansion, the density of this air body will actually reduce. So it will actually move upwards, right? This is actually happens with the fluids, right? This is actually happens with the fluid. Anyway, if you increase the temperature, the water, even in the water, yeah, very good example again, water. So water, when it actually the temperature increases, the particles near to the bottom of the pot, actually, or the water molecules that near to the bottom of the pot actually comes up to the it actually travels upwards, then the colder ones actually goes below, right? So this is actually known as convection, right? Next one is conduction, right? Conduction is where heat is actually transferred in solid objects. So solid objects, heat is actually transferred from molecule to molecule. It's actually transfer. So these molecule to molecule is transferring is actually known as conduction, right? The radiation means it's actually generated as electromagnetic waves. That's how we actually get the heat from the sun, because between the sun and us, that means between the sun and the earth, there's no environment, or there's nothing in between. So empty space, right? Empty space is vacuum. So in vacuum, we can't have convection or conduction. Only way to heat to transfer in vacuum is radiation, right? So radiation also is just the electromagnetic waves. So that heat then comes into the earth. In the earth atmosphere, we have a fluid. Through that fluid, we receive it into the everywhere else. So these through phenomena, so these three methods are actually being used in the vehicle. So radiation is used very small amount, and it's almost negligible. It's almost impossible to calculate how much it's actually taking heat away, and we do not actually consider about this radiation method because it's quite difficult to actually cool the engine just using radiation. But we mostly use this convection and conduction method. I'll explain these things when it comes there. So rather than just explaining the words, I just thought it's better to explain these two or explain these before we go in further. So cooling system, we'll start with the cooling system now. So cooling system actually can be classified, right? Can be classified. So we have direct cooling systems and indirect cooling system. So cooling system is more or less is a heat exchange, right? Heat exchanger means the components that exchange heat. So it exchange heat means the higher temperature of a body will be actually transferred to a lower temperature body, right? So that's what actually done by a heat exchanger. The heat exchanger design and the method and everything is different. This very simple example is the steam engines, steam, what do you call this? Steam. Yeah, steam trains also actually sort of or developed versions of a heat exchanger. Similarly, engine cooling system is also a heat exchanger. So direct cooling means the cooling is directly transferred to the body, and indirect cooling method means, it uses another substance in between the cooling, another substance in between. So we'll go ahead and discuss these things. So first we'll start with the direct cooling. Direct cooling, as you know, air cooling system. So it's very simple. Cooling system have been using for a long time, still being used in smaller engines, but there was a time these were used in very even for large capacity, high performance engines as well. So the system is actually very simple. What it does is um, air. So in this case, air is actually passed around the cylinder itself and allow it to cool by the passing air. That's how it actually works. So how this system works is, now you know the temperature is, or the combustion temperature happening here will be absorbed by the cylinder wall itself. So this cylinder wall transfer the heat. So the heat actually is, this is where the highest temperature heat, right? Then it actually transfer those through these cylinder wall, right? So this process, the heat transfer is actually conduction, right? So this conducting heat conduct through the cylinder wall, and it comes up to these fins, right? These fins. So these fins then transfer the heat from these fins up to the atmospheric air. So the atmospheric air, then what actually happens is, atmospheric air, then it actually use convection. From here onward, it's use convection to move hot air particles or air molecules away from the engine itself, right? So by doing so, engine actually reduces its temperature. So this whole process is actually known as heat dissipation or heat reduction. So the amount of heat reduction is actually depend on the three things. First one is the amount of air flowing around the fins. So how much of air can be passed through this? If there's more air flows through, or the higher the air speed around this, then higher the engine cool will be. And the second one is fin surface area. So that means how much of surface area is available. So for example, if we have a construction like this, right, only surface area we get is this much, right, this blue two line, right? But if we have a fin sort of arrangement, you can see it's already increasing the surface area. So this increase of the surface area means there's more area to contact with the air, so more heat can be dissipated, right? In addition to that, thermal conductivity of the metal used. So if this metal has a higher thermal conductivity, higher rate of air or higher rate of heat can be actually transferred faster. So high rate of air heat will be flowed through. That means heat will be actually reduced fast. So that's why most of the time these components or these air cooling cylinder barrels of this component, this part is actually known as cylinder barrel in this case. So cylinder barrels are actually made out of aluminium because aluminium has a very high uh, thermal conductivity. Okay, so I'm pretty sure you guys actually have a good idea how this works. But one thing I need to mention here is in these engines, the oil cooling system, so the oil inside the engine is actually playing a huge role, because since there's not much cool water cooling is actually happening, the majority of, in addition to this cooling system, air cooling system, uh, oil cooling, the oil system or this lubrication system actually helps a lot in cooling the engine itself. So in most of these engines, if it is like a large engine, not like a motorbike, if it is large engines, these actually need additional cooling as well. But in the motorcycles also, if you have look at the underneath of the motorbikes, they actually have fins underneath the engine bay itself just to cool this oil inside the gearbox and the transfer case. Okay, right. So it's actually showing how the fins are there just for you guys to see. So fins increase the contact area of the cylinder wall, in which in turns increase the heat transfer capacity. So higher the surface area, higher the heat transfer capacity. So higher the heat transfer capacity means faster the engine will get cold, right? Uh, yes, high heat transfer coefficient to transfer the heat. Yeah. So next part is the baffle. So this is so even though this cooling fins useful, there are few disadvantages. Few disadvantages being one of the problems with this system is airflow cannot be directed around, right? Airflow cannot be directed around it. One example is, let's assume you're cooling. So let me check. Take another color. So assume your cylinder barrel shape after having fins is something like this. The airflow would not actually directly follow this channel, right? Airflow will not actually follow this line. Airflow has some air means it's actually a fluid, so fluids actually have some characteristics. It can't take these sort of sudden like 90 degrees angle, so it will always try to travel some way like this, right? Even though this seems okay, now you guys can see there's a gap here, right? So there's a gap here. There's no airflow flowing around this area. So when there's no airflow around these areas, right, what actually happens is the temperature of this particular area, right, this particular area increases. right? That particular area temperature increases and it causes the engine to actually overheat, right? Overheat. So to avoid this, actually, we use something called baffles, right? Baffles. So baffle means a sort of like arrangement like this. So what we do is we have some arrangement like this and opening on top, right? We close this from the behind and then keep opening in top. So what actually happens now is the airflow actually has to come, right? It can't go back. It has to turn upwards and come out and then go out. So it will actually create more airflow around this area to cool this section here. If it's not properly cooled, there's too much temperature here and low temperature in the other areas. This could end up creating a crack because of the expansion happening in this area, this high temperature area into the other direction. So it's trying to expand this way, right? While rest of the block actually trying to push it the other way around. So it's trying to push this way, right? So as a result of this, too much stress could actually may create a crack. So to avoid these things and to channel more air around it, it actually used cowling, right? Or baffles. But there are another advantage of using the cowling. As I told you earlier, the engine actually needs to have optimum operating temperature, right? Optimum operating temperature. So in order to keep this optimum operating temperature, airflow needs to be controlled. So when the vehicle speed increases, that means it's gonna when vehicles speed increase, that means it's actually what it's actually going to do is it's actually going to increase the airflow around it. So heat transfer increases, so engine temperature goes down. So the heat transfer increase means engine temperature will drop. Again, we have a operating condition problem. So in order to maintain the operating condition, in such cases, airflow has to be controlled. Even though we now at this moment we can't actually reduce the speed of the engine or reduce the vehicle speed. So there should be a way to actually bypass these things and or close the airflow. So these sort of baffles can actually have something like a opening, right? There should be like a valve, right? Valve could be fixed in this, and once the valve is fully closed, for example, if the valve is open here, the airflow has nowhere to go, so air will actually stuck here, right? Or if it is the air intake is somewhere here, the air intake will be actually closed, right? This is very important in countries like cold countries like Europe and European countries, because they have extreme temperature differences in the seasons. But for countries like Sri Lanka, it does not make much of a difference, but other countries may have a big difference, especially when the engine operating in summer, it actually have higher temperature, where in the winter it's actually have a very low temperature. Okay, so that's what the purpose of the baffle. So baffle is actually used to like um, used to control the airflow around the cylinder, um, around the cylinder block, right? Cylinder block, or in this case, the fins. But in some cases, it may be too much. In such case, the baffle is used to actually close the airflow around it in order to maintain the operating temperature of the vehicle. So this is a very good example for a air-cooled engine. I think more of you know what is this vehicle is. This is actually called as a so this is actually is a Volkswagen Beetle. So I have actually explained what is this car and why this was manufactured and this and that. So this actually has a air-cooled engine. The air-cooled engine actually absorb air from these holes behind the or below the rear windscreen. So the airflow as shown here. So the engine is actually on the back, but there's no radiator here, no coolant. It's actually fully air-cooled engine. So that's one of the reasons for these vehicles to be so popular, because less maintenance, less components to be worried about. Anyways, the airflow comes over the top of the roof, and then it goes through these holes. That means the roof on the back, and that airflow goes into a baffle around here. So this is the section where baffle is there. Oh wait, I need to use the spotlight, right? So airflow comes over here, through here in this hole, through these holes, and it goes into the baffles itself. So this section is where the cooling is actually happening. Since this actually is a rear wheel engine, and this is a bigger engine capacity, large engine capacity, it's around 1000 cc to 1300, 1600 also was there, 1600 cc, that means cubic centimeters is there in this engine. The airflow is actually has to be higher. So for that purpose, this actually used a intake fan. So this actually use an intake fan. So because of that, even at low temperatures and low speed and everything, the engine is actually getting temperature from this fan. So fan is actually directly bolted to the alternator itself. So this is a alternator. It's actually a generator, because this is a very old engine. It's actually a generator. It's not an alternator. It's actually a generator. So however it is, this is how what used to generate the electricity. So this component directly connected to a fan over here, right? Fan over here. So that fan, right, what it does is that fan actually distributed, the suction air will be actually distributed around the engine itself, right? So if we look at from the behind of the engine as a cutway, open way, this is how it actually looks like, right? This is how it looks like. So this ducting actually represents this black color area, right? Black color area. So in there we have a oil cooler and the fan, right? Oil cooler and the fan. So when the fan is actually operating, it sucks air and it's circulated around this ducting, where it actually sends the air flow through the oil cooler, cooling the engine oil. Then there will be two additional openings over here, right? There are two openings over here. So those two openings will be around here, right? Will be around here. You can see there are two ducts over here, right? There are two ducts, right? These are the two ducts. So those two ducts openings are actually here. This is the opening, right? So this is the valve I was talking about. So at low temperatures, if the temperature is so low, like cold temperatures, in such case, these valves will be fully closed. So air will not actually pass through the cylinder block itself. So this is the cylinder block where it's actually located below this, right? You can see there's like a small sort of like a pan sort of thing, right? Below that is this section over here, right? So it measures the engine temperature, right? It uses a thermostat valve which controls the these doors here. So when this valve or door, valve, whatever it is, it's when it's fully open, right? When it is fully open, air is actually passing around the cylinders, right? Passing around the cylinders, cooling the cylinders. But when the vehicle is going faster, or if the temperature around it is low, in such case, these valves will be fully closed, right? These valves will be fully closed, and then there will not be any airflow around it until it comes to the operating temperature. Once it comes to the operating temperature, it's again opens and send the airflow around it. So this is how a normal air-cooled engine works, for especially for a passenger vehicle, right? Especially for a passenger vehicle, this system is almost trouble-free. It's redundant. There's nothing to go wrong. No liquids, nothing. It's very reliable system, reliable and very durable. Because of this simple system, these vehicles were very popular until recently, and still they are getting popular and known as classic vehicles. So system has been using this system has been used for long time, even though these particular vehicles were designed first in 1930s. late 1930s. Then it continued until around 2000. Until around 2000, this system was used in this particular model with various upgrades. But there are some pros and cons of using cooling air cooled engine, right? So number one is wait. Okay, so we start with the pros. Radiator pump is absent since the system light and simple. So system is very light, engine construction is easy, cost is low, less components, and since no coolant, that cost is going to be saved and maintenance is very easy. And one good advantage is very effective in cold temperatures. That means any area like Europe, it's very good. Even in countries like Sri Lanka, it's not a big problem for this. But efficient wise, it's low because metal has a big disadvantage because metal to air heat transfer, right? Metal to air heat transfer. Metal to air heat transfer is very low. The coefficient of metal to air heat transfer coefficient is lower than water to air through water to through metal to water heat transfer, right? So coefficient. So because of that, the efficiency is lower. When the engines are having higher operating temperatures, this system is quite difficult to use. But still, when the engines such as air cooled, so more such as these plane engines where this engine is directly open to the airflow, it still can be used. Even these gas turbines, so jet engines are actually air cooled. There's no such additional cooling system. It's completely air cooled. Like most of the air actually taken intake from the intake is actually used for cooling the engine itself, not anything else. But this particular system, even though it's at the moment, most people think this system is not that useful, but that's mainly due to these environmental changes. Environmental changes means uh, environment temperatures have been increased, so this actually affects this particular type of cooling system very much because the cooling rate will be reduced with the temperature increase. Even though until 1970s 1980s this system was very popular, and until like 2000 air cooled production cars were there. The or we call the sibling or the brother of this Porsche actually manufacture or design manufacture this Volkswagen Beetle, the one we discussed earlier. This car, this one is actually designed by Dr. Ferdinand Porsche. His next creation, the popular one, is the Porsche 911, which actually used a air-cooled engine until around 2098 or something. Then only it actually switched to the liquid-cooled engines. And in addition to that, the air-cooled engines were very popular got popular and developed by the Porsche until recent, and they even went racing with these engines. So this is the Porsche 917. This car is known as Porsche 917, and it's actually used a 12 cylinder. It's actually used a 12 cylinder engine. So this is the engine and gearbox itself. So this actually has 12 cylinders, flat or is horizontally opposed engine layout with 12 cylinders, and it's produced upwards of 1000 horsepower. Yet it does not have any cooling systems. It's only used air cool. So this fan over here at the top of the engine, this is the cooling fan for this particular engine. But you have to understand this engine purpose and everything is quite different. So even nowadays, what we have, passenger cars have around 100 150 horsepower, but this car produce around 1000 horsepower. The 100 horsepower engine is actually using water cooled engines, but this one only used air cooled engine, right? And this won the races and everything. It's not just normal race, it's actually ran for continuously for 24 hours, in one race. So that's the race. Those are called as endurance race. This particular car is designed to compete in endurance. So this engine also designed to run on endurance races. So which means is it's not actually simple as it seems. So 24 hours continuously the vehicle is driving or running upwards of 300 kilometers per hour continuously. So that means the engine and everything has to be perfect. So driver will be changed the middle, but the vehicle will not be allowed to change. So because of this system, they were able to develop even better models of this, and until 2000 or something it was used with the, especially with the emission regulations, strict emission regulations. The cooling of the engine became a very big issue. That's one of the main reasons to actually switch from air cooled to liquid cooled engine for this particular manufacturer. So at the moment no one is actually manufacturing any air cooled production vehicles at the moment. So next we move into the indirect cooling system. So indirect cooling system, as you know, it's actually the liquid cooling system we will be discussing. The oil cooling system we will not be discussing at this particular stage. So in this particular system, engine block and everything is quite complicated. As you know, you have learned about the block and block construction and all. So what it does is it actually has some we call them as coolant jackets or cooling passages around the cylinder, right? And so the block is engine block, or cylinder block itself is having two walls. So in between two walls, the liquid coolant is actually traveling, or it transfers, and it absorbs the heat from the engine bay cylinders itself, and it's the heat or hot coolant will be sent into a separate heat exchanger, which is known as the radiator, and the passing air through that will absorb the heat from that, and again the cooled liquid comes back to the engines and do the same thing again. So the rest of the process is recirculating the air coolant again. So whole system we can actually show like this, as you have already known about these things. So I'll start from the bottom of the heat exchanger or radiator itself here. So we have the coolant, the cold air water. This actually comes through the water pump. So this is the pump, right? This actually use a pump. It actually can operate without a pump also, which I'll explain a bit later. So what actually happens here is the water actually comes through the rubber hose here, then comes up to the pump. From the pump, it's actually pressurized and pumped into the hose, recirculated to the engine block. From the block, it actually travels around the block and goes to the engine head, right? Then it's traveled to the engine head and absorb the heat while it's traveling, absorb the heat and increase the temperature, comes up to the thermostat valve. So there's a valve here which, until engine comes up to the operating temperature, this will not open, right? This will not open, it will just bypass the coolant system. So once this valve is open, the coolant will then send back to the coolant heat exchanger or radiator, then passes down again, right? Passes down again through very small thin channels where air is actually being in contact with these channels around the channels, body of the channels, where it actually take away the heat. So in order to assist this heat transfer in the radiator itself or the heat exchanger itself, the engine again drives another fan here, right? Fan here absorbing air through the radiator itself, right? So by doing this, it's actually maintain temperature at a constant level. So this sort of cooling system is actually known as a pressurized cooling system. The reason is Well, the other type of cooling system is actually known as thermosiphon system. I will explain the thermosiphon system when I'm discussing about the water pump, right? So pressurized cooling system. So pressurized cooling system means the system or the cooling system is pressured, right? Operating temperature is around 15 to 16 bars, right? 15 to 16 bar psi, right? So the reason for having this high pressurized temperature is in order to increase the working temperature of the uh, in order to increase the working temperature of the water. So water's boiling temperature is around 100 degrees, right? 100 degrees Celsius at sea level, right? At sea level. When it goes over the sea level, the temperature or boiling temperature actually lowers. But at the sea levels, we have the highest air pressure, right? But if we increase the air pressure or the pressure around the boiling, right, air pressure, that actually increase the uh, boiling point of the water. So by doing that, water can actually absorb more heat. So water actually have something called latent heat of vaporization, right? Latent heat of vaporization. By increasing the pressure, the latent heat of vaporization increases. So more heat is necessary for water to reach up to the boiling temperature, right? Up to the boiling temperature. By increasing the uh, pressure of the cooling system, it is possible to maintain the water coolant boiling point around 150 175 Celsius. So if the engine goes even above that only, engine will actually start to boil, right? Engine will start to boil itself. So this diagram actually shows how the water boiling temperature actually increases with the pressure around it. So when the pressure increases, you can see the graph, how the graphs change shape is actually changing. So with the increase of the pressure, the bar angle is also increasing. So to maintain this pressure inside the system, right, it's actually uses special components called the pressure cap, radiator pressure cap. So this is what the radiator pressure cap is. So by using this, engine actually capable of maintaining higher temperature. So in order to increase the temperature pressure of the system, it's the water, by water circulating again and again, it's actually increase the temperature. So this part I already explained. So water, now the pressurized system, water is actually passing through, and it goes back to the radiator and again get cold and comes back, right? So this with this system, it can actually absorb more temperature, right? More temperature. The thermosiphon system, I'll explain the thermosiphon system again without the water pump instead of going for the water pump. So in thermosiphon system, it does not actually use a water pump. Instead of using the water pump, it's just a completely a closed system. What actually happens there is when the temperature increases around these cylinders, right? When the temperature increases around the temperature, that water actually flows upwards, right? Flows upwards. If you can remember the basic concept of the convection, which is right here, as it says, movement goes within the fluid by the tendency of hotter and therefore less dense material to rise, and colder dense material to skin under the influence of gravity. So that means here, when the temperature increases around this area, around the cylinder itself, right, water around the cylinder actually try to move upwards. So when it try to move upwards, the water on the top, since it can't go down now, it's also trying to move up. It's also pushed upwards. Since this is moving upwards, the water that cools and on the bottom of the radiator tank actually comes to take that place, right? Try to come and take that place. So this particular phenomenon is actually known as thermosiphon, because the temperature water is actually siphoning or circulating around the system, right? But this system has some issues, especially this system can actually generate a lot of what you call this air pockets, right? It could actually generate air pockets very easily. So to fix that, the water pump is actually used to circulate the water coolant around the system. Okay. So coolant passages are they are inside the cylinder block. I told you earlier also. So you can see the cylinder blocks here. So these cylinder coolant jackets. So coolant passages are here. So these are the coolant passages. So this is a cutway of a cylinder. This is a V engine. So this is your crankcase, right? This is your crankcase. These are the two cylinder walls, and you have your main journal supports here, right, or bearings here. Then you have the cylinder walls again. I told you this. This is what actually is the your coolant jacket is. This is your coolant jacket is, right? Coolant jacket or coolant passage. So it goes all around the cylinder itself. And if you can notice, it's not going everywhere. It's just this section over here, right? This section over here, because below there, there's nothing to cool. Actually, that area is actually cooled by the oil itself, and these are actually the oil galleries. Here is the main oil gallery. From there, it's actually channeled up to these. From there, it's pushed upward. So that's how the engine block is. And the engine head also. This is how the engine head's coolant passages looks like. It's difficult to show here, but these small holes, right? Sorry, green ones. So sorry, this is the coolant ones, right? Coolant ones are these green ones, right? So green color ones are the coolant passages, right? So the coolant actually flows from bottom. So that means coolant actually travels from here. It goes upwards, right? Then comes through the uh, cylinder head and move back to the radiator, right? Move back to the radiator. And these brown color ones, right? Light brown color ones over here are actually showing you the how the oil is actually supplied into the engine head itself. So the cool camshafts are lubricated by this, and the return oil, right? Oil return, as I told you, it's actually returned with the gravity flow. These huge openings are there for oil to return back to the cylinder, back to the crankcase itself. So the coolant passages, again, we come to the coolant passages. So these are the coolant passages which goes around the cylinder. Then it comes to the engine head, and then cool the engine head, top of the engine head. Then it's moved outwards. Okay, so once we combine all of these things, the whole system looks like this. Right? All things look like this. Give me 1 second. Yeah, without all the other components, now you can actually see the whole cooling system. I will explain from here, right? I will explain from here. Let me start with, there are two scenarios for engine to actually operate. So one is engine starting, right? I will start with the engine starting scenario. So at starting, so assume that engine is kept in this, right? Kept like this. So when they add engine starting, right? Engine at the engines. No, I'll explain these things again. So we have the radiator here, right? From the radiator, the water actually travels through the water pump into the engine block, right? And the engine block. From the engine block, Then it's after traveling around the engine, it comes back to the thermostat housing. So this component is thermostat housing, and there's a valve here which is known as thermostat valve. Through the thermostat valve, it actually comes back to the radiator. And before goes to thermostat valve, you might have seen there's a opening here. Right? There's an opening here. Right? Sorry, there's a bypass line here. Right? There's a bypass line here. So the purpose of this actually is to keep water away, or the water will not allow to actually to the travel to the radiator itself until the engine got higher up to the operating temperature. So at the starting, the morning, the engine is not actually at operating temperature. So it's around 25 degrees Celsius, assume, right? It's not 25. So at this particular instant, this valve is actually closed, right? This valve is actually closed. So there will not water actually traveling through this way. Instead of water is actually traveling this way, right? So water is actually traveling this way and comes back up, goes through the engine until it comes to the operating temperature. Until it comes to operating temperature, it circulates around it. So then once it's come to the operating temperature, that's the at operating temperature, this valve, right? This valve, this is actually known as a two-way valve, so it's actually can close and sorry. Now this valve opens and it closes. This side opens and this bypass valve is now bypass line is closed. So the water is actually now flowing through the radiator, cooling it. So it goes through. It's cold. It's getting colder and comes back down, and it goes through the water pump and recycle it. But in case if the engine temperature goes beyond the below the operating temperature, again this valve will actually comes back to the same condition as the starting condition. Then water will actually flow through the bypass, right? It will actually flow through the bypass valve. One second. So that's how the system works. We'll just discuss about each and every component, what sort of components being used here. So we'll start with the fan. Fan actually responsible for drawing the air flow. Drawing means actually sucking air through the radiator. It's not pushing, it's actually sucking air through the radiator. So these radiator fans actually have two types. One is mechanical type, other one is electric type. So fan actually do not needs to work at all times. Over around 60 kilometers per hour, the vehicle's radiator is not radiator. The amount of air getting travels through the radiator is enough. So in such case, the fan does not actually have to work. So to fix this, there are two methods have been used. One is using electric fan, right? One is using electric fan. The other one is using a mechanical fan with the fluid coupling like this. So this is actually known as a fluid coupling. So you can see here, the fan is in the mechanical fans. So fan directly usually connected to the water pump itself. So if the fan is not running in some cases, that means probably water pump will not also rotate. But how this actually works is there's a fluid here, right? There's a fluid here. So when this fluid is actuated, so at a certain temperature only, so above certain temperature only, this fan and the inside components will be actually connected. So over certain temperature, fluid coupling is actually connected. So the fan blades are rotating. But below that temperature, blades are not rotating, only the center of the this fan will be rotating. So that's how this system is actually working. So the electric fan, as you know, it's actually has a sensor module, or we call it as electric fan switch, right? Rather than using a sensor module, it's actually using electric switch because it's simpler. So it is actually switched on and switched off by that particular electric circuit, which we will discuss later. So basically, most of the newer versions means like front wheel drive vehicles. So that means the engine is actually fixed in transverse layout, right? So in the when engine is specially fixed in transverse layout, cooling system or cooling of the engine is a difficult purpose because the mechanical belt driven system is difficult to use. In such case, uh, these sort of electric fans are used, but in the other longitudinally mounted engines, they actually mostly use this fluid coupling type. But even with the low transverse engine assemble, it's possible to actually use mechanical coupling, but it's quite difficult to actually uh, fit the belt. But there are some applications. One good example is Toyota, not Toyota actually, Peugeot 305 engines. They actually have transverse engine layout, but still the fan is mechanically driven. The belt, they used a belt driven system to do that. The belt can actually turn into 90 degrees with proper arrangements. So that's what the purpose of the fan. Now we move into the thermostat, the purpose of the thermostat. So as shown here, thermostat, as I told you earlier, the operation of the thermostat. So the bottom image actually shows you the thermostat. So here is the thermostat. So how thermostat system is actually designed is it's actually fixed in a housing where it's always open for the bypass valve. So it's always open at the bypass valve, right? So water is actually not flowing back to the radiator itself. It's always open to the bypass line. So this is the bypass line. So coolant flow comes here, and it's bypass. It's open through the bypass line, right? Flow goes back to the engine block itself. But once the engine comes up to the operating temperature, the bypass valve actually opens, right? Bypass valve actually closed, and the coolant flow started to flow through this valve, right? Through this thermostat valve into the radiator, right? So this actually has sort of like a wax capsule inside, right? Wax capsule inside. So once it's actually liquefied, this valve is completely collapsed, right? This valve will be completely collapsed, closing the bypass valve. So the operating or this actuating or the wax capsule actuating temperature is equal to the engine's operating temperature. So it's not possible to actually change the thermostat valves with another engine because each engine's operating temperatures are somewhat different within like 5 degrees. But unless it's not exactly same, it's not actually changed. So thermostat valves should not be changed. So if you move to the next slide, right? So this actually shows the whole operation, right? Whole operation of the system. So you can see over here, the water is actually coming back to the water pump. Then it goes to the water coolant, goes through the engine and comes back to the thermostat housing. But since the engine is cold, it's returned back to the pump and return back to the, it comes back to the engine block itself. So until it's come to the operating temperature, this thermostat valve will not actually go open, right? It will not actually open. So once it fully once it's got into the operating temperature, this will completely open and the water will actually start to flow through. Okay, so this is how the operation is. I'm sure you might have already learned this thing in your practical or video practical. So we'll move back to the radiator. So radiator exactly is a heat exchanger. What it does is the temperature, the heat of the coolant traveling, or coolant actually flows inside. It's actually exchange that heat with the temperature, with the air that flows through it other way around. So that means for this particular application, so for this particular example, right, in this particular example, right, coolant is actually flowing this direction, right, and your air flow is actually traveling this, sorry, air is actually flowing this direction, right? Coolant is flowing in another direction, and airflow is traveling to the 90 degrees from that direction. So that travel actually provided the contact surface area between these two coolants, right? So this particular application is actually known as heat exchanger. That's what actually shown here. So this is the hot coolant traveling through this red line, and the colder air comes through, and hotter air, high temperature, increased temperature, cold air actually comes out of this heat exchange. That's what actually happening in a radiator itself, right? So radiators are, there are different types of radiators. One, basically these radiators are classified based on how the radiator arrangement. So even though it seems like only one row of flow is there, but there could be more than one row. So that one particular row is actually known as a core, right? So this whole section is known as a core. I'll just show you the next slide. Just better. So this is the radiator itself, right? So you can see there are two types of radiators shown here, right? Two types of radiators, and each components, or the names of the each component. So these two types of radiators, the difference between, the main difference between these two radiators is where the tanks are. So radiators has two tanks. One is hot tank, other one is cold tank, right? So based on the location of the tank, the water flow can be actually determined, right? Water flow can be actually determined. So uh, if there are two tanks on top and bottom, that's actually so sorry, yeah, so that sort of arrangement is actually known as a downwards flow radiator, which is very common type of radiator. The other type, so this sort of type, so that means the water is actually flowing from left to right or right to left, is actually known as a cross flow. So this is a cross flow, this is a down flow, right? Radiator. So these sort of radiators are mostly, so the type of radiator used, it does not matter whether it's a downwards flow, the crossward flow. Only thing is design for the reason for decision this type of radiator is what type of, or how much of surface area is available for cooling. So for applications like diesel vans and sort of applications, they will use a radiator similar to this. Even the bigger engine capacity, if the engine capacity is higher, the more coolant capacity needed, this sort of arrangement may be most useful, because this arrangement means the radiator is going to be taller. So by using this, you can see the directional, the space between these two hot tank and the cold tank is higher compared to this. So more cooling effect can be actually obtained by this. So in such cases, this type of this type of radiator will be utilized if the cooling, if higher cooling capacity is necessary. But in addition to that, there are other ways to actually achieve the similar effect. One way is this part. So this whole section with the cooling fins and the water flowing lines, right? So that is actually known as core, right? This section is known as radiator core, right? This arrow is actually showing the through the radiator core. So if you look at here, there are 1, 2, 3 lines, right? One, two, yeah, 1, 2, 3 lines. So there are 3 lines that actually transfer water from the upper tank. So that means top tank and bottom tank. This is the bottom tank. This is the top tank. This is the, in the other case, this is the let's say hot tank and cold tank. So yeah, so this is hot tank, right? Top one is the hot tank. In the inlet from the engine means it comes to the hot tank. So hot tank to cold tank. So the bottom tank is known as the cold tank. So from hot tank to cold tank, you can see there are 1, 2, 3 lines of lines actually going. So this sort of arrangement is actually known as 3 cores. So each line of water flows, right? Water channels actually known as 1 core, right? So that means this particular radiator has 3 cores, right? In this application, right? In this application, that means the cross flow application, again you can see 1, 2, 3, right? 1, 2, 3, right? So again you have 3 cores in this particular radiator type. So same, instead of increasing the surface area from the width or height, the same effect can be achieved by adding another core. So the radiator size will be actually smaller, but the cooling effect will be similar. So that's one method actually used by these Honda Civics. They actually have a very small radiator, but how they do is they have 2 cores rather than having one single core, right? In addition to that, as you can see, both of these radiators actually have transmission coolers inside. This is a common setup. This is a common setup, especially in the auto gear vehicles. They have a transmission cooler, and it's actually fixed inside the engine. It's actually fixed inside the engine. It's actually fixed inside the radiator itself in order to cool the transmission oil. So that's the basics about the radiator. So why today everyone is turning on their microphones? Right. So next we will move to the radiator cap, one of the most important components in a vehicle. Right. So even though this is a very small, simple component, failing of this particular components could end up ruining complete engine, right? Ruining the complete engine, right? So as I told you earlier, the engine has to actually maintain the pressure, right? Maintain the pressure. In order to do that, it's actually using this pressure cap or radiator cap, right? It's actually a pressure cap, right? So it's actually maintaining this pressure by using a spring, right? By using a spring, right? So you can see there are 2 springs here, one spring here, one spring here, right? Let me try to explain this one like this. So this particular so this is number 1 seal, right? There are 2 number 1 seal is here, right? So that's one here, right? That's where once we close this is where it's going to actually seal it from. Once completely close this is where it's actually going to close, right? In addition to that, there are two, if you have seen the radiator opening, right, it's actually have like a neck sort of arrangement, right? So that neck arrangement is actually shown by this is the neck arrangement. This is the radiator neck, right? So that neck actually contact around this, right? Then we have another two openings, right? Two valves. Let's say two valves. So valve number two here, that's number two valve. So number two valve here, if you look at from the bottom of it, this is number two valve. You can't see it. This is number two valve, right? So that's actually mentioned as lower seal. So number two valve is the lower seal, right? And you have another valve, right? That's over here. I need a color. Hopefully you can see this. Okay, number three valve here. So number three in this case, this is number three, right? So what you have to understand is how these are actually operating. So if we look at these two valves, right? So we have number one. That number one means the purple color. That's a complete seal. That's known as upper seal and lower seal, right? In addition to this lower seal and upper seal, there's another valve called as number three valve, right? Or vacuum valve, right? So number three is a vacuum valve. Number two is a pressure valve, and number one is complete seal, right? Upper seal, lower seal, and vacuum valve. So vacuum valve, lower seal, and upper seal. Let me explain one thing. So these two are number two and number three. That means lower seal or pressure valve and the vacuum valve. Those two are actually operated by spring load. So these are the springs, right? This is one spring and this is another spring, right? And these are only one-way valves. These are only one-way valve. So if we look at this vacuum valve, it can only operate this way, right? It can only goes that way. So when it is opening, it moves outward from the caps, right? It moves outward from the cap. But if we look at the pressure valve, right, it can only move upwards. It can only move upwards, right? That's all you only have to understand. So lower seal can be opened upwards, vacuum valve can open downwards. At the moment, that's enough. So even though these two valves are moving up, whether it's moving up and or down, up or down, either one of these valves, at all times the upper seal is completely sealed. So it's not open in any way, right? It's not opened in any way, right? Did you get that? I hope you all understood up to there, right? So you have three valves and this is how it works. So this operates in three scenarios, right? This actually operates in three scenarios. We'll go ahead and look into these, each of these scenarios. Is there any way I can move all this? Right. So these are the three scenarios, right? So now the valve is completely sealed, right? Completely sealed, right? Okay, assume that your vehicle is now, you started the car and you are driving your car, right? No coolant system, nothing is there. So you just started and you are driving and vehicle is actually moving. So this is, at that time it's like this, right? Then after you drive for some times, the engine temperature rises and your RPM increases, and because of that, the pressure inside the system, right? Pressure inside the coolant system is actually increased, right? Pressure inside the coolant system is increased. As a result of that, now pressure valve open. Pressure valve means number two valve, so it can only move upwards. So once this is completely open, right? Once it's overtook the pressure of this spring, right? That once this, so this is your number two and this is your number one, right? So once the pressure increase, this valve will move upwards, right? The number two valve will move upward. When number two valve is moving upward, this vacuum valve will not move anywhere because it's still keeping it closed. So as a result of it, this water or this coolant will actually flows out, reducing the pressure until it comes to the predetermined value. That's around 15 psi. As I told you earlier, it should be around 15 psi. Until it comes to around 16 psi, this valve will keep it open. And once it comes to the 16 psi, it closes again, right? It closes again, and temperature is maintained, the engine operating is maintained, the engine have no issues, right? Engine have no issues. So since the temperature increases, this valve open, the liquid coolant went out, and the engine is running fine, right? That's what actually happens usually. So in addition to that, right? So this is what the normal operating condition. So after it's completely open and the system goes up to the over the pressure limits, this opens and the liquid coolant is sent out. Then valve is again closed, right? Once it closes, it comes back to this scenario. That means pressurized system, right? So now the pressure is maintained again until the vehicle is until the vehicle is come to the correct temperature, right? Until the vehicle is actually, if in any case the pressure increases or something, again this valve open and maintain the pressure and comes back to the correct position as this, right? So this continues up to until the journey, right? Until your journey finish. So once you comes and once you turn off the engine, now engine started to actually cool down. So what happens when the cooling down is, now the pressure or the temperature reduces. When the temperature reduces, the pressure inside the system automatically drops, right? Pressure inside the system automatically drops. So in such case, now the pressure drops, say the engine is having 15 psi now, right? At the stopping, it's actually having 15 psi. Now it's going 14, 13 like that, start lower. So when it is actually lower, this vacuum valve start to open. So when the pressure is dropping, this vacuum valve open again. Since there's a vacuum inside, now here the coolant from outside or coolant from the, your reservoir tank will be actually sucked inside or absorbed inside until it's reached again up to the correct pressure. Once it comes to the correct pressure, again this will actually close until it comes to the operating condition or operating pressure, right? It comes back to, or it's actually comes up to the sorry, not so this vacuum opens and it's release the pressure, and until it comes to the usual temperature. That means usual what you call this atmospheric pressure. Until it comes to the atmospheric pressure, this valve opens and closes, open and closes. Once it comes to operating condition, atmospheric conditions, this stays like this until again you start. Once you again start, now system has too much pressure. Again, this valve open and sends the liquid out. Right, sends the liquid out into the your tank, right, reservoir tank. So you fill the reservoir tank again, right? That is why you have a reservoir tank, and that is why reservoir tank has high and low points. You should not fill over the low point, sorry, over the high point. Right? Hopefully you all understood the operation of this. I actually put some videos also at the end of this presentation. If you wish, you can actually go ahead and watch them as well. So next we'll move into the recovery tank. So, or reservoir tank, also known as reservoir tank. So the pressure from this, once the valve is completely open, right, high pressure at the, when it is having high pressure, the liquid coolant is coming back here. So if it is over max limit, it will actually come up to and fill it up to here, right? Then once the pressure actually drops again in the system, once the engine is completely turned off, when the cooling is happening, the coolant is actually sent back inside, right? Right, so that's what actually done by this reservoir tank, right? So as I told you earlier, max and min is actually mentioned there because of this particular reason, right? So this particular reason, it should not actually fill uh, over the max limit. It should be maintained at max limit. So yes, we move, yes, this photo actually showing how the radiator cap is fixed here. From the radiator cap, as you said, as I told you earlier, so the neck is there. From the neck, the pressure valve opening, this opening comes up to this tank over here, right? So this, I'm not exactly sure whether you guys can see these, but here it's actually using two core radiator, so it's not going all the way to the radiator stay, which I will show you in a separate video. So this is where the radiator is actually, and so this is a two core radiator, so it's not going all the way in the front of the vehicle. So hoses and clamps used by the radiators are an important part. It should be able to maintain the pressure and should not actually crumble or open break during the operation. In addition to that, there's a one important task of these radiator hoses. As you can rub or these radiator hose components, the main important purpose of these is, as you can see over here, engine is over here and it's actually fixed into rubber mounts. It's actually rubber mounts, and it's allow the engine to move a little bit. It allow the engine to move a little bit because of the vibrations and the torque generated by the engine. But as you can see, radiator is completely fixed with the body of the vehicle itself. So this flexibility between these two joints is very important in order to maintain the maintain the connections very well. So that maintaining this, in order to maintain that, radiators actually use these rubberized holes. So these rubberized holes, usually these are synthetic rubber, or in such case, in high performance applications, these are actually made of silicon, right? Silicon rubber hoses also used. So advantage of using silicon rubber hose is actually low thermal conductivity. Low thermal conductivity is important here in order to maintain the temperature in the engine bay itself. So these clamps also used to fix the radiator hoses. These clamps actually comes in inches, right? Inches. So they usually comes like half inch, 1/8 inch, half inch, like this. So that's the standard way how to actually find the inch size. Inch size or millimeter size is also available for these. Okay, so the complete coolant system is somewhat different from what I actually explained to you guys earlier. So this actually shows a complete coolant system, right? Complete coolant system. Before I move into the electrical part of this coolant system, I'd like to discuss a little bit more about this complete coolant system. So if we start from the beginning, right? So as you can see, coolant is travel, right? Coolant from the radiator is actually goes through the all these hoses and everything comes back to the engine and through the pump and back to the radiator. So this part is somewhat similar, but there's a small, there are some changes, right? There are some changes here. So you can see this tank is somewhat different, and this tank is somewhat different, right? This tank is somewhat different, and the connections to the tank, instead of it's directly connecting to the radiator hose, this valve here, it's actually connecting into the from the so from the reservoir tank, it's directly connected to the hose itself. So this is the modern system. This is modern system. So rather than direct, rather than having this cap over here, it operates in the same way. It operates in the same way. If the pressure increase in the system, this valve will open and send the coolant back here, right? If the pressure increase, it's actually sent back here, right? So one advantage of this system is it does not need to actually bleed the system. It does not need to bleed the system, because this particular hose here, it's actually used as the bleeding hose. If there's any steam or any water pockets, it should actually comes out. So one more thing, if we look at, if we go back, I need to go back. Okay, so if you look at here, one thing you guys, we always have to remember, so this radiator pressure cap, right? Radiator pressure release cap in this case have to be on the highest location of the engine. It always have to be on the highest location of the engine. So during this operation, if there's any air pockets generated, that air pockets, because of the high temperature, it's I always try to move up, right? It move against the gravity. So when it comes to this, if it is if this is not the highest position, if it is not the near the pressure, highest position is not the pressure cap, in such case these air pockets will actually gathered in some other place, increasing reducing the efficiency of the or air flow inside the or reducing the effectiveness of the cooling system, or it may actually ended up damaging the engine itself as well. So always the pressure cap should be on the highest position in the engine itself. But using these sort of application, by using this sort of application, since the coolant actually the system can actually even without this system, it can actually, since the pressure actually move through another hole, the vacuum is actually moving another hole, so another opening is there for vacuum to move. So because of that, it does not actually need such a application. So in addition to the particular normal radiator coolant system, there's another addition here. So this part, right, this part. So this is actually the engine cabin heater, right? Cabin heater. So as you might have seen in the air conditioning system, there's a red color part and a blue color part. Blue color part is the air conditioning system, and the red color part is the heat system. So heater system is actually operated by the heat of the engine itself, right? Heat of the engine itself. So it uses the heat of the engine, or the engine heat. The heat absorbed by the coolant will actually transfer through these lines. It will transfer through these lines and come back, sent back, actually sent back, sent back the heater core, and it comes back to the engine again. So the airflow, that blow fan actually sent airflow through this section here, heater core. Heater core is again a some sort of a radiator itself, but its size, dimensions wise is smaller and the capacity is smaller. So then the airflow traveling through that sends through that, and that heat actually, that absorbed heat of the air actually comes to come and transfer to us, right? That means the passengers inside. So this system is used in this. This is we call this sort of arrangement is a high waste heat recovery system. right? So basic word is waste heat. So wasting heat, the heat is actually going to be waste. It's going to pump out and it's going to dissipate it out. Instead of dissipating out, that heat is used to actually warm the cabin itself. So that's why it's actually called as a waste heat management system or waste heat recovery system. In addition to that, one small change is there in a modern, very modern, like very new coolant system. That's actually the water pump. So even though water pumps in the previously, as I told you, it's driven by a belt. Nowadays, water pumps are actually electrically driven, right? Electrically driven. That means there's no belt. It will be an electric motor running the water pump, and also there's no thermostat valve since the water pump is not it's electrically controlled. The thermostat is also not necessary, as water pump can switch on and switch off as necessary. This system is especially used to maintain or generate the maximum amount of energy for, or use the maximum amount of energy from engine to actually run the vehicle. In addition to that, there are a few other advantages of this system, especially like hybrid vehicles. When the engine is turned off, if the coolant needed to be sent through motors and other components, in such case, having a normal water pump means just to cool the motor components, the engine has to be turned on. By having electric pump, it can be actually solved. In addition to that, by using an electric water pump, engine can actually work a bit more efficiently, because the power of the engine will not be used to run the more electric pump itself, and it's not necessary at all times. Only when it is necessary, it will be actually driven itself. We'll discuss this part when we discuss about the electric engine management module. So next I'll move into the cooling system electrical part. So basically there are two electrical sections related to this. So basic electrical systems, right? So not the advanced one, just discussing the basic electric part of the cooling system. So there are two electrical systems related to engine cooling system. So number one is radiator fan switch, right? So that means radiator fan switching on, switching off circuit, and coolant temperature gauge, which shows you the temperature of the engine itself, right? So those are the two most important parts of the engine. So we'll move into the first one, radiator fan switch. So radiator itself is actually radiator fan itself is actually having a complete circuit in the four, just to switch on and switch off the fan, right? So how it works is a very simple arrangement. So it's actually use a relay system. It's actually uses a relay system just to turn on and turn off the fan itself. The thing about the fan is it's actually drawing a higher amount of energy or higher electricity or higher current. Actually, it's in higher current. So the thermos switch or this electric fan switch directly could not actually control the fan itself. So to solve this, it's actually by using the thermo switch, right? Thermostatic switch. We call these as thermostatic switches. So this, by using this particular switch, we turn on a fan relay, right? Fan relay, and yeah, fan turn on the fan, fan relay, and by using the relay, it will drive the fan itself. So as you can see here, so this is the, so this one and this one are both are actually radiator fan switches. But later also I will show you in the next slide the fan switches and the thermal sensor, the temperature sensor. By looking from outside, it's impossible to identify which one is which. Right? There's only one way to actually check this, just by testing or right reading the model number like this and finding out what sort of application is there. So you can see here there are two pins. This one only having one pin. Both are available. Whatever it is, as you can see, there are two pins, and in that two pins, the operating is actually given here, right? So there's on and off, right? On at 90 degrees Celsius and off at 85 degrees Celsius. So at 85 degrees Celsius, engine fan will turn off, right? But if it is goes over 90 degrees, it will turn on, right? That's what it's actually mean. Either reading, you have to read this, or you actually have to test this by putting it into hot water and testing the temperature, checking the radiator resistance. I'll explain how this is different in the next. I think there's a diagram. So yeah. So fans is a specially manufactured module. Its actually resistance only drops to 0 ohm over specific temperature. So in this case, once it goes over 90 degrees, the temperature, if the coolant temperature goes over 90 degrees, the current will allow to pass through this. Current will allow to pass through this means that means what actually happens here is the switch is turned on, right? Turn on at over 90 degrees, but once it goes to 85 degrees again, the switch will turn back off, right? Turning off the fan, right? That's how this actually works. So the basic circuit is here. So the direct voltage, or once the ignition switch is turned on, the power is come to these two circuits. So number one circuit, so this one goes through a fuse and comes back to a relay. So this relay actually drives one relay actually drives this thermostatic switch here. So the power comes through here and comes back up to there, right? So once comes up here, and through that it comes to thermostatic valve, right? So thermostatic switch. But until the temperature goes over 90 degrees, right? Over 90 degrees, this is closed. So there's no electricity pass through. So the electricity will not go, and it will not be earth, right? It will not be earth until it goes to earth. We have to wait. Once it goes to earth, the electricity will start to flow, right? So once it goes to 90 degrees, earth will be connected, so electricity can actually flow. Now electricity is flowing, so this will activate the magnetic switch inside the relay, so which in turn send the power through the fuses again through the relay into the radiator fan. So fan start to work until thermostatic valve or switch turned off at 85 Celsius degree. So once it goes to 85 degrees Celsius, again they switched off. So no current here. That means no current coming to the relay main circuit. So relay is turned off. So in turns, it turns off the fan itself. Right? That's what actually happens here. So very simple circuit. But if you go to the temperature gauge sensor, it's somewhat different. Gauge sensor is somewhat different. The difference between the temperature, based on the temperature, as shown here, based on the temperature, the resistance of the this particular sensor module is changing. So it's not only changing at a particular temperature, it's actually gradually changing, something like this, similar to like a graph like this, right? So for this particular sensor, it's actually shown here, but as you can see over here in the image A, the previously, if you consider this one and this over here, there's no difference from outside. Both looks the same, right? Both looks the same. So gauge wise, the operation gauge is very much similar to the what we discussed last time, because of the variable resistance, the magnetism change around here. So the pointer actually moves left or right based on that. So here it's actually the material used inside of this actually change the resistance based on the temperature, right? That's how it's actually works. So very simple system. Only way to actually distinguish these two, if you do not know the model code or anything, only way is to put both of these into a hot like 100 degrees Celsius um, sort of like a hot water tank or something, and check the resistance. If the resistance is dropping slowly or increasing slowly. Oh yeah, one more thing. Either this could be more temperature resistance increasing, or it could be temperature reducing. Both ways can be used, and circuits can be designed both ways, because just by replacing these two other way around, it works in the same way, right? Similarly in here, in this case, what you can do is, again, if you check, you should be able to actually find out if the temperature is dropping completely. So if the temperature is dropping completely, resistance, if the resistance is dropping or increasing, around 80-85 degrees exactly, that means that's the switch, right? It's a switch, it's not a sensor gauge, right? If the other one, if it's other way around. So if it is actually reducing or increasing gradually, that means it's a sense, right? That's the only way you can find if you don't have any other details regarding this, right? So I think this one is clear. If you have any questions, you can actually ask me. Yeah, so we'll little bit discuss about the coolant. I would like to add some more details to this. It is possible I'll add after this class also. So coolant, there's one very important reason for adding coolant, right? So in our case, like countries like Sri Lanka, coolant is not actually doing much of a difference, right? Coolant is not doing much of a difference unless the manufacturer actually asks you to use the coolant. The reason for using coolant is this was actually originally started by because of the freezing of coolant inside the engine block, right? So engines actually have a so if it is like colder environment, such as like European countries or Canada or some very northern countries of the world, they have a tendency that coolant, that means water, ended up actually then becoming a solid inside the engine bay. In such case, a starting engine is not possible because the fan is now completely stuck, water pump is completely stuck, right? So it could create, or it could damage the engine. So to fix that engine could, so because of that, engine could not start in these cases. So what actually these what had to be done is to have a coolant, right? It has to have some sort of an antifreeze ability. In order to give this antifreeze ability, uh, coolant was actually developed. So in addition to giving this antifreeze ability, it's also resistance to the rusting. So engine bay water, if the water is actually there, it's actually ended up rusting. Especially engine block is not going to have any problem. Engine head is not going to have any problem with the rust because they are either cast iron or aluminium. But the rust is going to be a problem for the water pump. And if you have a um, uh, what do you call this wet, some type, not wet, some, sorry, wet liner type, it may, the liners are steel, and steel is very much uh, very happy to be rusted. So because of that, coolant needed to have rust. So this water does not have this water actually tended to rust the metal, and they tend to actually get colder and dense, right? So to avoid this, the coolant is being used, right? So coolant is being used. So coolant actually increase the rust resistance and increase the antifreeze ability. So it will not freeze if you use coolant. So in addition to that, so basically coolant is actually made out of glycol based coolant. These are actually glycol based coolants. We use 50-50, or in some cases we actually have other different coolants, especially if you are using like electric vehicles. The coolant is not water based, they are different. You might have seen like blue color coolants are there. That's the electric coolants are there in order to avoid electric shock and causing unnecessary trouble. So that's why they are actually there. That AdBlue system is also there. That's related to emission system. That's nothing to do with coolant. I have heard some people are saying that it's coolant. It's not coolant. AdBlue system is completely a different matter. So So the coolant usually is green color, red color, different colors. So I'll try to add some details more into here. I forgot to add that actually. So basically, most of the time, normal vehicles like normal day-to-day vehicles usually use around green color one with the particular given with the particular coolant ratings, and it's actually mixed with water. So when we are mixing with water, it's not just tap water, it has to be distilled water. It has to be distilled water. You mixing it normal water will not actually affect the coolant, so it has to be distilled water. It should always be distilled water. Distilled water means battery water. Usually call that battery water. So it has to be mixed with battery water and fix it there. In modern vehicles, if modern like very modern GDI engines, they actually use like the electric coolant, especially because of the electric water pumps and because of especially of the electric water pumps and other electric components. Some actually have this electric motors and battery systems that cooled by the coolant. So because that they actually use different types of coolant, right? So with that, I will. This is that's all actually. That's all regarding the coolant, right? That's all regarding the cooling system. We'll be discussing this topic again, not this deep, just about the controlling of this system. I have added some reading materials, additional reading materials with this. Hopefully you guys can go ahead and read these things and watch these videos. You'll be getting more and more details, especially since you guys have not done the practicals yet, or physically not done the practicals yet. So with that, I'm ending today's class. So if you have any questions, you can actually ask.